Hello everybody, we'll be reviewing PR number 31549 related to first testing. Board of system time is called without mock time being set. So this is a PR related to improving the stability of first tests. So first of all, like first tests are run to check if our code that we have written is able to perform as it should on some extreme scenarios. We might uh, so in generally what we do is when we are testing a code, what is testing a piece of code that we have written, we will have like set of tests that we will run to check if it is working as it should, or the basic functionalities of the test are being like fulfilled. So these are like just basic like cherry pick tests to check if they are working, and these those tests are not taken, or like if these tests are working, it should be working for all the test cases. So that is the assumption we take, that the test may or may not fail at some other piece of like other corpuses or test cases that we might not have written for our piece of code. So it is not feasible to write all the test cases. It is not also feasible to like determine what are the extreme cases sometimes that we might like with that we might face. So first test helps in that scenarios. What first test do is that it will generate random inputs to be tested in the test in the piece of code that we have written, and it will check for the all the assertions that we would have taken in the code, and like if any piece of code fails that assertion, the first test would flag that this test case has been a case of failure for this piece of code. So this is how first tests work. So now what in this PR is being improved is that there is a sort of currently a sort of instability in the piece of first test that we have. So like looking into the PR, what happens is currently for taking the time of when like the test is run, the first is take system time as an input in like uh, in the mock time like creation code. So that is a piece like that is a piece of a case of non-determinism where a test input that is not controlled by us is being uh, introduced or being included in the test, which may lead to non-determinism. So stability in a first test is being referred as whenever we like input the same then whenever we provide the same inputs to the first test, we will get the same result 100% of the time. So that is what we define as stability. And what was happening is this system time may be different for all the like devices that we have. Sometimes like a person in another time zone will be having different output for the same set of inputs that we would have given, and that he also would have given, but just because of the time zone difference we are getting different outputs. So that is not really what like that is not desirable, and this PR like aims to remove that. So we are introducing a set mock time function in the CheckGlobals utility, where set mock time irrespective of the time zone the device is being used at, it will set a mock time in the first test so that there is a set of determinism in the piece of code or in the first test that we would be like writing. So looking into the file changes, uh, we can look at this. So we are using set mock time with a consume time first data provider. So what consume time does is first data provider is like instance of this first data provider block that provides us with random data to be thrown into the test. So what consume time does is it will just take the random data that we would have got from this first data provider, and then it will convert it into like time in uni value so that this set mock time can use that. So this is what uh, is being done here. So now what happens is that what would have happened previously is that this since set mock time would not have been used, we would be the mock time that we would have used would be dependent on our system time. It would have caused like non-determinism in our first test. So for most of the part, this is just uh, introducing set mock time utility to whatever piece of code that was using this system time as a input to introduce mock time in its code. So most of the initial part of the code that uh, is like new here is this. So we are introducing a G used system time variable. This piece of code, what this piece of code does is, if some piece of code is using system mock time, and or if some piece of code is using system time, and uh, the mock time is not being set, then it would flag an error that uh, this first target is accessing the system time, which might cause like non-determinism in the code, which is not something like desirable, and it should be better to replace it with that mock time. So this would flag this like flag that piece of first target that would be using the system time. So we are introducing this get used system time here. So this is the CheckGlobals utility. This utility itself has been introduced to like increase the stability of the piece of first targets. So uh, so in this piece of code, we are introducing a bool variable where we are writing where we are showing if our piece of code in the first target has accessed the system time. So yeah, this set gets us this system time if being used variable is being used here to determine if the piece of code that we would that would be using the system time. So what is the flow of this is that whenever we would be using a first target, whenever it will like start running, if uh, if the piece of code uses use system time, it would turn the variable to true, so it would be written somewhere in piece of code. Yeah, so whenever a code like accesses system time, this node clock now function like is would be called, and uh, whenever we enter this function, this getUseSystemTime variable is turned to true, uh, meaning that we have accessed system time to whatever, like whatever thing we would be doing, where we would be accessing it for. And initially this variable is default to value false. Yeah, and then if we access this function, which just means that we are using system time, this variable will turn to true, and then it will check if this is used here in the same CheckGlobals utility. Okay, so all of this is just is using the set mock time. So there are some pieces of code uh, where we have used set mock time differently. So one of this is, yeah, here. So we are using first data provider with set mock time, and here we see is that we are using a minimum value to be set. So this value here is what uh, what is our reg test genesis block timestamp. So this is the instance of when the genesis block was mined, and anything less than that is an invalid value. So we should not be using that, and that should not be generated by the data provider first data provider. If it is generated, discard it, and then use some other value. So like we would check here to check the definition of this. There are a lot of instances where it is being used, so might take a while. So this is the function definition. Just a little more. Okay. Yeah, so we are using a set mock time instance. There is like there should be another instance where we can also put a minimum amount like specified here, and whenever we have some minimum value, we should uh, not be using that. I guess it is in consume time. Yeah, it was here. So we have the first data provider that would be providing us with uh, random inputs that we can use. We have two optional variables, a minimum value to be set and a maximum value to be set. So initially we are defining this minimum as this and maximum as this, and the first data provider should return a value in this range. So this is how we can like set if we want our data to be if we want our first data to be in some sort of range. We can't use intervals right now, but we can only set one range only from a minimum value and then to a maximum value. So this is why there is a minimum value here. Another instance being which is yeah. So of putting uh, instead of putting a set mock time, what we have is we are using a constant value of mock time. Originally, it was using system time. So now what happens is we will be calling consume time once, and this will set a specific mock time which would be random, and that would be set as a constant, and we would then call our like testing setup with that value. We have like first initially there was only test activation height, and now we are also setting a mock time value to the mock time RPC with a specific mock time value that is being set here. Uh, yeah, and this first tester just is like called here to just access the first data provider. Another portion of code that has been uh, like changed is this. So initially, this setup common we if you would have seen is commonly used in non-first piece of code. So if you would have written a unit test somewhere, you would be like you would have like set a, like you would have imported this setup common utility. So it generally resets the set mock time to 0. So what it was doing is that it would have set mock time. It would have like set a set mock time to 0, which in fuzzing would have been like overridden with another set mock time instantiation with a system time input. And for like unit tests, this set mock time would have remained the same. So now what we are checking is that if we are not fuzzing, then only set mock time to 0, else we would have like instantiated this set mock time uh, already in the piece of code in the first test target that we would have been using. So as you can see, like in every piece of code we are setting mock time explicitly, and like this is yeah to just remove this set mock time being instantiated twice, we are using this. Okay, so now just to let you know how uh, set uh, this would be working, how first test would be working is you can just look into this fuzzing.md in the docs, and you can steps to follow here. You can follow the steps here. And for macOS people, I think there is a little bit of issue right now in the CMake with this lib fuzzer. So you can check the issues here, or like just uh, like there is an issue related to that also, which they are working on currently. So we have to use some other methods to like we just have to use LLVM 18 as of now. LLVM 19 is not supported. So what we can do is we just if when you have set up and configured the Bitcoin core repo with fuzzing setup, you can just call fuzz local, or fuzz is equal to any target that you would like to fuzz, and then call the fuzz binary and just then enter. We would be having a lot of these fuzz random inputs being uh, used, and then there are a lot. Uh, these are the results of the lib fuzzer output. Uh, we can also maybe see if uh, this PR is following what it is claiming. So I guess I'll have to rebuild it. Now, what we will do is we will just uh, change. We will not be setting mock time to any of the target, any of the specified target. So just we will change the load external block file CPP. Okay, so we'll just comment it out and then build it. Would be good. And it might take a while. Until then, we can just see. So this is a SHA-256 hasher uh, with that is used a lot. There are a lot of other algorithms too. Like I guess C-Shake is also being used here. RIPEMD is also used in Bitcoin Core. So just we can see that if let's say I'm in time zone uh, 13, I guess let's just say hypothetically I'm in time zone 13 and the current time is 13 in my time zone. So I get 13. So you can see the output has changed a lot. This is the properties of hashers, that whenever you change even a little piece of code, you will see a huge change in output. Uh, to You'll see a huge change in output that will be given out by the hasher. So for the time being, let's assume that some constant and other constant are like something that we control, and hasher is the one that will generate uh, that output, and this is a variable that represents our system time. So this is not something that is in our control. So if you can see that if I'm I have changed my time zone and now I'm in time zone 15, you will see that there is a huge change in output that we are observing. This is something that we would not want. Some reasons that I can highlight are like it would be difficult to reproduce bugs that would that some people report if there's a change in time zone. Also, like some updates also trigger a change in time system time. That is also an issue. And like in general, we are losing on our deterministic property, which is also a huge loss. Basically, what is happening is I'm getting a new hasher every time I'm in another time zone and I'm using another system time, which is something that is bad because we are not like controlling all our inputs that we are putting in the hasher. We would like to control all the inputs that we are like inputting in our hasher. And okay, so the target is has been built. Okay, and there is no change. I don't know how. It should have crashed and it is not crashing. It is working fine. Just make sure I'm on the same branch. Strange. I don't know if like anybody else has like set up already. If they can check on their own system if changes are like introducing a crash in the system. So same behavior on both sides, but with some runtime errors. Mm, Okay, so I'll just check it up after the club. Uh, we can for now uh, just answer the questions for this PR club. So the first question is, what is fuzzing and why is it used? So if anybody would like to answer this.
Oh, I
Am I
think,
audible?
yeah, you're audible. I will answer this question. I think
Okay,
the
okay.
fuzzing is just a technique like in which we test the reliability of a system by like by some random inputs, some unexpected inputs, and after providing that kind of inputs, we check where there is any memory leaks or buffer overflows in our program or any invalid pointer, like something like this. And after this, we can like discover many vulnerabilities in the system, and we can work on the improvement of the overall system.
Yeah, correct. Yeah, that is absolutely correct. So the other question is, what is stability in fuzz tests? So if anybody would like to answer this.
So stability, I think, simply means like if you provide the same input, the same problem input to the function or a program, then the output every time you will receive is same. There is no change in the output, whether whether until you provide the same type of input. So the input and output must be reliable and same. Like no matter how many times you call the function, whether it's a single time or 1,000 time you calling the function, the answer should be relevant and same on each iteration.
Yeah, correct. Like just how uh, coding P like I wrote, it is the same as reproducibility. We should be able to reproduce the same outputs with the same set of inputs. Yeah, a little bit. You can say that stability is almost the same as determinism. Like it should be deterministic in that with the same set of inputs, we should be getting the same set of outputs and not there should be almost no change in like our input and output mapping. It should be the same since the fuzzer has not been changed. So yeah, why replacing system mock time is important for the stability of fuzz tests in Bitcoin Core. Like why has been like basically why has set mock time base been introduced in the current piece of code? Yeah, correct. If like if we are using system time to mock the time, we would be losing on determinism and reproducibility of bugs and other test failures. So yeah, that is why it is important to introduce this. Okay, so like how is set mock time improving the stability of first test? So this is the same as why we are replacing system time. It is to just ensure the reproducibility of the output given a set of inputs. And yeah, this is basically it. So how is the code identifying the piece of code using system time in the code? In the code of first target that is uh, being utilized. So like basically, how can we determine that a piece of code in the first target is using system time to mock the time in for itself?
I think there was a if condition with the variable g underscore something. I think that condition
Yeah, so
specifies.
yeah, so whenever this system time is called, there is also a function now being called. So what now does is now will determine from the adaptive like the system that your device is using. It will determine what time is it, and then it will then use that as system time. So it is mandatory for that now function to be called whenever we are using system time, and whenever that now function is called, we are setting the variable g using system time as true, which was initially false, which would that system time to uh, the mocking the data, like mocking the time for it itself in the target. Yeah, so like that's about it for the questions. Thank you everyone for joining. We would, like, if anyone is able to reproduce like the change, like the desired output in Linux machine, happy to like include it in GitHub issue. Like,
Thanks,
yeah,
thanks,
so
Abort, for hosting, and thank you everyone for coming up. Thanks.
yeah, thank you for joining.